In today's video, we're going to learn about Thomas Young's experiment. After watching this video, you should be able to just get a general understanding on how Thomas Young used the diffraction of light to explain why light has wave-like properties. Okay? Basically, it was this debate, what is light? For a long period of time, people didn't really know. Like, do you classify light as, matter? What is it exactly? Is it a photon? What's going on here? And basically, the debate continues to this day, but for right now, what we need to worry about is how does Thomas Young have an argument to say light actually is a wave? And it's through his experiment that people can kind of point to saying, oh, because light can diffract, we can call it a wave. So let's get right to it. In 1801, Thomas Young devised and performed an experiment to measure the wavelength of sunlight, and it was a pretty clever experiment. Basically what he did was he used a pinhole in one of his windows. So he made a really small hole in the window. Now this picture is much larger, or the hole in this picture is much larger just to kind of show it, but it's a really tiny hole, a little pinhole of light in a window, and a mirror and a small paper card. And basically this paper card split the sunlight into two different beams, and by splitting them into different beams he could cause constructive and destructive interference to occur and basically show that light is able to diffract. Okay, so here is Thomas Young's experiment and maybe how we can run it in class. Instead, we're going to utilize a laser, and then we're going to have two small slits, and we're going to shoot this laser beam through these two small slits, and the light is going to be projected onto a wall or a screen, and the screen will show bright bands, which are represented here and here and here. All these red dots are the bright bands, and that's an area of constructive interference. The dark areas are areas of destructive interference, and basically what this is showing is that sound waves, water waves, waves in general are able to undergo diffraction. And it turns out light is able to do the same thing. It too is able to undergo diffraction. And that's what Thomas Young's experiment was all about, was basically taking sunlight instead of a laser, this was sunlight, shoot it through a small card and basically cause it to diffract. And he was able to say, well, based on a bunch of math and stuff that we weren't going to really get into, by being able to calculate distances and all these different things, he was able to calculate the wavelength of sunlight and again show that light is actually a wave because it is able to undergo diffraction. This is Young's equation, and we'll probably use it as like a class lab or experiment, and here it is in all of its glory. Lambda equals the wavelength. Okay, so wavelength equals y, which is the distance from antinode to antinode, or these bright spots. Okay, so how far apart is this? Okay, what's the distance there? D is the slit distance, which is in this little picture. How far apart is the hole that the light is traveling through? Okay, and typically it's going to be a pretty small number because the slit has to be pretty tiny to cause light to diffract. M is the order number, which was talked about in the previous lesson. Okay, so remember it starts at 0 in the middle and it works its way from right to left or left to right, either way, 1, 2, 3, and so forth. And this would also be 1, 2, 3, and so forth. Okay, so that's the M. And then L is the distance from the slit, if in this picture here's the slit, to the screen or the wall that you're projecting this on. Okay, and basically if you start throwing these numbers into this equation here, you can start finding out the wavelength of whatever it is that's producing the light. Okay, and that's how Thomas Young was able to do this. Alright, so that's a real short video, but it's an important idea that you guys understand that waves that light is actually a wave, and the reason, one of the biggest reasons we're able to point to saying that light is a wave is because it's able to undergo diffraction. I will see you guys in the next video.